Simplify each radical expression. In order to simplify a radical expression, what I need to do is I need to get the prime factorization of what's under the radical, the part we call the radicand. So what I'm going to do is this. I'm going to break down all the parts inside there into as many just factors or prime factors as I can. So that means I'm going to take the 8 and I'm going to try and divide it by my first prime number, which is 2. When I get 8 divided by 2, that gives me 4. It's a nice even number, so I know that that 2 is a prime factor of 8. Alright, that left me with 4, so I'm going to take 4 and I'm going to try the first prime number again. Divided by 2, well, that would give me 2. So I know there's another 2 in there. And now my answer is 2. Well, 2 itself is prime, so I put that in there. And now I have all my prime factors of 8. 8 is just 2 times 2 times 2. A nice way to check and see if you've done that right is if you take all those and multiply it together, it should give you that. 2 times 2 times 2 is indeed 8, so that's correct. And then a to the 4th is a times a times a times a. That 4 just means we're multiplying a by itself 4 times. And so we end up with that. And what we're looking for here is we want things that we can move outside the radical, that we can take out from under here, that we can simplify. And the way we're going to do that is we're going to look for pairs. There's a pair, there's a pair, there's a pair. And I'm going to rewrite all of this using a property of radicals. And by rewriting this, 2 times 2 just means 2 squared. So what I'm going to do is I'm going to write that 2 squared under a radical by itself. And then I'm going to say times, and then that next part under a radical by itself. And then a times a is a squared. And then a times a is a squared again. And this is something that you can do with radicals. If everything underneath is multiplied, you can't do this if there's addition or subtraction signs. But as long as it's all multiplied, we can separate it up and give each thing that's being multiplied its own radical. There's nothing wrong with that. And now what we can do is we can simplify some of these. We know what the square root of 2 squared is. Taking the square root and squaring something are inverse operations, so these two will in effect cancel each other out. So the square root of 2 squared is 2 times the square root of 2. We don't have a way to simplify that. The square root of a squared is a, and the square root of a squared is a. And so now if we multiply all this together, we get 2 times a, which is going to be 2a squared, and then we have times what's left here, which would be 2. So our simplified version of this would be 2a squared times the square root of 2. Alright, now that is the answer, that is the solution. Let me show you another way of thinking about these that might be helpful. So this is just the same thing done in a slightly different way. It obscures what's going on with the math a little bit, but it might help you work the problem easier. So we've got all of this, which is the same. And I had 2 times 2 times 2 times a times a times a times a. And again, what I'm looking for is any groups of 2. So there's my groups of 2. And what you can think of doing is just pulling these groups of 2 to the outside of the radical. But when we do this, you can sort of jokingly think of this as a marriage chapel. Yeah, there's 2 of them when they go in, but when they come out, they're one couple. So these 2, when it comes out, it used to be 2 2s, but when it comes out of there, now it's just 1 2. This used to be 2 a's, but when it comes out of the radical, now it's just 1 a, and we're going to multiply those. And when this comes out, it's just another a. And then we look at what all we had left under the radical, and the only thing we had left under the radical was a 2. Multiply all those together, and you get 2a squared times the square root of 2, which is just what we got before. So whichever one of these ways is most helpful for you in thinking about what's going on, feel free to do it that way. All right, let's look at number 2. Number 2, we have negative 3 times the square root of 384v. So what we're going to do is we're going to get the prime factorization of this just as we did before. And I'll go ahead and do that down here. Let's get our prime factorization of 384. It's a fairly large number, so this might take us a couple steps. So we get 2 works, gives us a nice round number. Now we take that answer, 192, and we try and divide it by 2. We get 96. Now let's try and divide that by 2. We just keep using 2 until 2 doesn't work anymore. So there's 3 times. 2 works again, and again, and yet again, once more, but now we're left with a 3 at the end. 3 is prime, so that 3 goes there. So that one breaks down into a huge number of these things. We can check to make sure we wrote this out. We have 2 times 2 times 2, 2 times 2 times 2 times 2 times 3, and it all totals out to 384, so we know we've done that right. And we have times v, just one v out there. So I'll work this both ways so that we can see what's happening. Working it this way, I look for groups of 2, and that's all the groups of 2 that I have. So I'm going to say this is negative 3 times the square root of 2 squared times the square root of 2 squared, so that comes from there, that comes from there, times the square root of 2 squared times the square root of 2 times the square root of 3 times the square root of v. And I'm off screen. There we go. Now you can see the rest of what happened there. So now let's simplify. We have negative 3 times, well, this can be simplified. That's 2. That can be simplified into a 2, and that as well. And now for this stuff, we can't simplify any of that. So what we can do is when you're multiplying these, that's the same as saying 2 times 3 times v, all under one radical. And now I can take negative 3 times 2, which is going to be negative 6, times 2 again, which is negative 12, times 2 again, which is negative 24, times the square root of, and inside here we have 2 times 3 times v, which is 6v. And so there's my answer. Now I'll work it the second way in the hopes that maybe that'll catch a few people that may not have got the other way. My word, that's a lot of 2's. All right, so we look for groups of 2. There's a group of 2, there's a group of 2, there's a group of 2, and that's it. We're going to bring them outside the radical, and when we do that, remember they are shrinking down into one thing. So what we do is we take negative 3 times that 2 times that 2 times that 2, and remember they're squishing down into 1 as they come outside the radical. And then inside the radical, what I have left is 2 times 3 times v. And simplifying this all down, I get negative 24 times the square root of 6v.